Good afternoon all. This is Satish Kumar. Now let us see the video lecture series on linear time invariant continuous time systems, that is nothing but LTI systems. See, linear time invariant systems are characterized with the help of differential equation, impulse response, block diagram, state variable description and transfer functions. What is mean by differential equation? It is used to represent continuous time linear time invariant system. It relates the input and output of the system. X of t can be applied to the differential equation which can produce the output as y of t. Differential equation has two components, natural response and forced response. This is the differential equation system. When we applying the input x of t to the R and C, that is nothing but system which can produce us the output as y of t. Impulse response, it is a decaying exponential function. It can be represented by h of t with respect to t. It is a step response. It is a rising exponential function. With respect to step response is nothing but u of t. What is mean by system transfer function? Ratio of the output to the input. H of s is equal to y of s divided by x of s. Frequency response, s can be replaced by omega, is can be equal to h of omega is equal to y of omega divided by x of omega. How to find the inverse Fourier transform? X of t can be applied to Fourier transform which can produce as x of omega. That can be applied to frequency domain analysis which can produce the output as y of omega. While we are applying the inverse Fourier transform, we can get the output as y of t. Condition for a linear time invariant system to be causal is nothing but h of t is equal to 0 for t less than 0. Condition for a linear time invariant system to be stable is nothing but summation k is equal to minus infinite to plus infinite. Modulus of h of k should be less than infinite. What is mean by impulse response? Impulse response is the output generated by the system when the unit impulse is applied at the input. X of t is nothing but del of t can be applied to linear time invariant system which can produce the output as y of t is equal to h of t. Del of t is equal to condition 1 for t is equal to 0, 0 for t should be not equal to 0. System transfer function can be defined as h of s is equal to y of s divided by x of s. How to find the impulse response of the system? While we taking the inverse Laplace transform of h of s, we can get the impulse response of the system. Next one, time domain into frequency domain. The x of t can be applied to Laplace transform which can produce this as x of s. While we applying the Laplace transform of h of t, we can get h of s. Y of t is equal to h of t into x of t. While we applying, we can get it as a y of s is equal to h of s into x of s. By applying inverse Laplace transform to s function, we can get time domain sequence. Y of t is equal to h of t into x of t. Next one, this is the another time domain to frequency domain representation. Time domain, it can be represented as full sine wave, can be represented as t with respect to amplitude and time. That can be converted into frequency domain. It can be represented in terms of 1 kilohertz. The complete sine wave can be divided into 2. We can get it as your cycle t by 2. While we applying converted to frequency domain, we can get 2 kilohertz with respect to amplitude and frequency. How to find the impulse response of the system? First, we can going to find the differential equation. From the differential equation, we can apply the Laplace transform and algebraic equation and then solving for roots. While we are applying the inverse Laplace transform, we can get the impulse response of the system. Next one, convolution integral. Any input can be expressed during the unit impulse function is nothing but convolution integral. X of t can be applied to linear time invariant system which can produce output as y of t. Y of t is equal to t into x of t. Y of t is equal to input function into impulse function. X of t into h of t. Therefore, x of t is equal to integral over minus infinite to plus infinite x of tau into del of t minus tau into d tau. Next one, properties of convolution integral. It can be divided into three properties: commutative, distributive and associative. Commutative, x of t into h of t is equal to h of t into x of t. Distributive, x of t into h of t, h1 of t plus h2 of t is equal to x of t into h1 of t plus x of t into h2 of t. The left hand side sequence, x of t can be applied to h1 of t plus h2 of t, which can produce as output as y of t. X of t that can be applied to h1 of t plus into x of t applied to h2 of t. Now we can going to add these two signals, we can produce as output as y of t. Now we can associative property x of t multiplied with h1 of t again multiplied with h2 of t, which is equal to x of t into h1 of t into h2 of t. The left hand side sequence, x of t can be multiplied with h1 of t again multiplied with h2 of t, which can produce output as y of t. Right hand side sequence, x of t multiplied with h1 of t into h2 of t, which can produce output as y of t. Now we can see the assessment. Define linear time invariant system. See, linear time invariant system is going to analyze the linear time invariant systems in terms of Fourier transform and Laplace transform. The system transfer function is given by h of s is equal to y of s divided by x of s. List the properties of the convolution integral. It can be divided into three properties: commutative, associative and distributive. DAX relates the input and output of the system. Differential equation relates the input and output of the system. What is meant by impulse response? The del of t can be applied to the linear time invariant system, which can produce output as h of t, impulse response of the system. The condition of an LTI system to be causal is given by h of t is equal to 0 for t less than 0. Associative property is defined as x of t multiplied with h1 of t again multiplied with h2 of t is equal to x of t into h1 of t into h2 of t. The condition for an stability of an LTI system is summation k is equal to minus infinite to plus infinite. H of t dt should be less than infinite. Thank you.